Okay, so we're going to talk about the basics of algebra. One of the most fundamental parts of switching over to algebra from basic math, also called arithmetic, is the introduction of variables. A variable is simply a letter that represents an unknown value. Okay? It's a letter that represents an unknown value or a changing value. It could be unknown or it could be changing, okay? And we'll actually see some that are both over the course of this class. So it could be unknown, it could be changing, but either way, it's not a fixed number. Okay? So usually the kind of regular variable that we use most of the time is the letter x. Okay? So, but you can use any letter you want. So let's write down some examples of variables. Okay? X, y, we even use z. We could use a, or we could use b, or we could use c, or we could use m, or we could use even some Greek letters like the letter beta, or the letter alpha, or the letter gamma. Okay, these are all okay to use as variables because they are just letters that represent a changing or an unknown value. Okay, most of the time we will use English letters. We will not use, or I guess they're Roman letters. We will not use Greek letters, but you can. A lot of times in physics they use Greek letters. So I want to build on this by introducing the words coefficient, expression, and equation. Okay, so a coefficient, an expression, and an equation. A coefficient is a number written before a variable that represents multiplication. So this is just the number. Notice that this is just a number. A coefficient is just a number. Okay? So if I was to write down something like 3x, okay, 3x, this is the coefficient. So this right here, this 3, that is the coefficient. And then the x is the variable, obviously. And so I'll do that in blue. And so this is the variable. But what 3x means, so what 3x means is that we are taking 3 times x. So this means 3 times x. This is what this actually means. Okay? 3 times x. So you can imagine that there is a little tiny dot right there to tell you to multiply. So altogether, this thing altogether, 3x, is an expression. So an expression is a combination of coefficients and variables and operations too So an example would be 3x, or maybe 3x minus 2, or maybe 4x minus 9, and so on. These are, there are an infinite number of these. Okay? I'm going to change that to plus. Now, an equation is a combination of expressions that involves an equal sign. So notice that expressions just had operations in them. Okay, just operations, and then an equation has an equal sign. All right. So an example here would be maybe 3x minus 2 equals 4. Okay? Now some of you may be looking at this and saying, oh, well, if 3x minus 2 equals 4, then x has got to be 2, because then this would be 3 times 2 minus 2 is 4. Don't worry about that. We're going to get to that. We will have plenty of exercise with that. So all I want you to do right now is recognize that this is an equation because this is an expression. This is an expression. And so is the 4. Even though it doesn't have a variable in it, that is still considered an expression. So these are both expressions. And then, of course, the key here is that it has an equal sign. That's what makes it an equation, is that it has an equal sign. So another example would be something like 3x minus 2 equals 4x minus 9. That would also be an equation. Because it has an equal sign, it's an equation. Okay? So the next part we're going to do is we're going to look at properties. Now this is a very important part of math, and I want to make sure that we go over it very clearly. Okay? I'm going to be using a lot of these vocabulary words all year, so please make sure that you understand this. A property is kind of a rule or a way that something works. If you're into video games, it's one of the rules that governs the environment that the game is played in, and like things you can and can't do. Those are properties, and so we have properties in mathematics also. Okay, we have the additive identity. By the way, I'm gonna label this properties. Okay, so we have the additive identity, which says that any number plus 0 is the same as 0 plus that number is the same as that number. But we already know that. That makes sense. So if you have an additive identity, then you have a multiplicative identity, which if you're adding 0 and it doesn't change anything, then what do you think you're going to be multiplying by? Well, you're going to be multiplying by 1. And it doesn't change anything. So you can take any number times 1, and that's the same as 1 times that number, which is the same as that number. Okay, this a can be any number. Remember, it's an unknown value. Okay. You also have the multiplicative property of 0, which is different, which says that any number times 0 is the same as 0 times that number is the same as 0. So if you take any number and multiply by 0, you're going to get 0 out of it. And by the way, the fact that we're saying that you can write this either direction, you can either write the a first or the 0 first, we already know that because it doesn't matter which order you add or multiply in. Okay, and that's another a property we're going to get to in just a second called the commutative property, but we've known that for years because you could say that 4 plus 2 equals 6, but just as likely you could say 2 plus 4 equals 6. The order doesn't matter. You can also say 2 times 3 is 6, or 3 times 2 is 6. The order here doesn't matter. You can add in either order and you'll get the same thing. And the same goes for multiplication. So that's all that's saying. And we'll learn what that's called in just a moment. We also have the multiplicative inverse. This is like the opposite, the multiplicative inverse. Okay? And so that says that any number times its reciprocal. And I'm writing this as a fraction because we can actually write any number as a fraction, and you'll see that. Well, almost any number. Times its reciprocal is 1. Okay? So for example here, a and b are any numbers, and you could say that a is maybe 4 divided by 1. Well, 4 over 1 is just the number 4. But if I multiply that by 1/4, I'm going to get 4 times 1 over 1 times 4 equals 1. Any number over itself is 1. And the reason that this works is that if you notice here, we're switching. The b is going there, and the a is going there. And so essentially all that is saying is something called the commutative property. And we're going to get to that in just a second. I keep talking about it. But what this is saying is that a times b and b times a are going to give you the same number. And when you have that same number over that same number, you're going to get 1 out of it. Okay? Now, let's talk about the reflexive property. Okay? The reflexive property says that any number is equal to itself. That's what it says. And I know that that seems kind of obvious, but it's still called the reflexive property. The symmetric property says that if a equals b, then b equals a. Pretty obvious, but we still name it, and it's called the symmetric property. The transitive property says that if a equals b and b equals c, then, can you guess it? Then a equals c. And we can see that very obviously because if a equals b, but then b, and see this is where it's matching up, but if b equals c, then we can just get rid of that and say a equals c, which I think makes a lot of sense. Okay? And the last of these is substitution. The substitution property says that if a equals b, then b can be substituted for any a. So if A and B happen to be the same thing, then you can swap them out and everything works okay. All right? Now, we're going to talk about the commutative property, and we're going to talk about the associative property. These are probably two of the most important ones to really remember in algebra, and these are ones that you have not seen before. The commutative property says that A plus B equals B plus A, and it says that A times B equals B times A. The order doesn't matter. Now, we already talked about that way up here when we talked about the additive identity and the multiplicative identity, and also the multiplicative inverse. If we say that A times B over B times A, well, what we're saying is that AB over BA is the same thing. And we're saying that the order doesn't matter if we're just multiplying. So you can add in either order and you can multiply in either order, and your result will be the same. The associative property says that if you're adding three things, and you group, now notice what I'm doing here, and if you group these two things together, it's going to give you the same thing as if you had grouped those two things together. And the same goes for multiplication. A, B, C, A, B, C. If I multiply those, it's the same as multiplying those first. So again, the order doesn't matter for multiplying and adding. And because subtraction and division are the same operations, just in reverse, the same thing can be said for them as well.